You made it. Congratulations. You completed this introductory course in linear algebra. Just a little recap along the way, we looked at things like systems of linear equations, vectors, matrices, linear transformations, subspaces and bases, determinants, eigenvalues and eigenvectors, diagonalization. But I'm making this video because really this is only the beginning, and I want to just point out some kind of things you might do from here. Just the big picture, linear algebra provides a language for representing and analyzing high-dimensional data. So vectors can represent data or states, matrices describe transformations, subspaces capture structure, bases provide efficient coordinate systems, eigenvalues and eigenvectors uncover structure, stability, long-term behavior. These ideas appear throughout mathematics, science, engineering, economics, and computer science. Some specific applications of linear algebra that you may encounter or maybe already have encountered include computer graphics, video games and animation, robotics and autonomous vehicles, physics, engineering and scientific computing, medical imaging, economics, finance and statistics, data science, machine learning and artificial intelligence, search engines and network analysis, quantum computing, to name a few. There are certainly others. And I want to dive even further into this idea of data science and artificial intelligence, since it's such an important topic in our, kind of the way the world has been going lately. Many modern machine learning algorithms are built on linear algebra. So examples include recommendation systems, facial recognition, image classification, speech recognition, self-driving cars, and another big one, of course, large language models. So large language models such as ChatGPT represent words as vectors and perform billions of matrix computations during training and inference. So really the backbone of LLMs, which are, of course, shaping the world we live in today. Some applications we, didn't really look at, but you're sort of set up to explore further include least squares regression, principal component analysis or PCA, singular value decomposition or SVD, some numerical linear algebra topics, optimization, abstract vector spaces, and tensor methods. Each of these topics builds directly on ideas developed in this course. There's also a beautiful example in our book, David Austin's book. It concludes chapter 4. I didn't make a video on this, but you're definitely set up to read through and take a look at this example, which is on Google's original page rank algorithm, which can be understood using linear algebra. The web is modeled as a Markov chain, so web pages become states, hyperlinks become transitions, and then the PageRank vector is the steady state vector. This is a beautiful application of eigenvalues, eigenvectors, and the Perron-Frobenius theorem. And not only is it beautiful, but it's obviously very, very important. The world we live in today is again sort of shaped and continue to be shaped by companies like Google and this original PageRank algorithm really was paramount in kind of the way the internet works. And then if you want to learn more, some wonderful resources include on YouTube. So Essence of Linear Algebra by 3 Blue 1 Brown. If you have not watched those videos, then you should definitely head over there. Really, really amazing visualizations of a lot of the topics we explored here. I think that they're good to watch, even if you've completed a whole course. Maybe even better if you've completed a whole course on linear algebra. Also good to watch sort of while you're studying or in advance of studying. But I think once you have a good feel for kind of the nitty gritty computational piece of things, going back and exploring those videos is really, really good. There's also Gilbert Strang's MIT OpenCourseWare lectures, which you can find, give more in depth and a little bit more rigor. And then, of course, our textbook, David Austin's Understanding Linear Algebra, which hopefully you were going through sort of while you were watching these videos. That was the intention. But if you haven't, then definitely go back and do some of the sections that we covered. But you can also continue along. So the book includes 3 additional chapters on linear algebra and computing, orthogonality and least squares, and singular value decompositions. Kind of in general, just keep exploring. Linear algebra is one of the most useful and beautiful subjects in mathematics. And thank you for watching. I hope these videos have helped you both, have helped you build both an intuition for linear algebra and an appreciation for its beauty. So I really hope you enjoyed, and I appreciate you watching.